All right, just wanted to give you a little bit of help on this review sheet for this test coming up, covering the topics of matrices, probability, and statistics. So let's get started. My first problem here is to come up with a 2x3 matrix, and they identify the elements, what they are and where they are to be placed. So first of all, 2x3, when you're looking at the dimensions of a matrix, it's always in terms of rows and then columns. The first number will always represent a number of rows. Rows run horizontally. So there are 2 rows and there are 3 columns. All right, so rows run left to right. Columns run vertically up and down. So I've set up a 2-row, 3-column matrix called A. And these indications are what the elements are and where they are to be placed. So just like dimensions are in terms of row and columns, first number is the row. That's also true for these little subscripts. So the first number is the row number. So I'm dealing with the first row and I'm dealing with the second column. So that element is the number 1 in that position. This is talking about row 2, column 3, which is way over here at the bottom right. That should be an 8. Row 2, column 1. So here's row 2, column 1. That's the number -2. Row 1, column 1. That's the top left. -4, row 1, column 3. Here's row 1, column 3. That's the number 5, and then there's only one number left. Row 2, column 2 should be a 0. All right, so that completes problem number 1. On 2 through 4, maybe 5, I've cut that off, but I think it's 2 through 5. You're doing multiplication. This is called scalar multiplication, number 2. And it's pretty easy. You're just going to multiply 8 times every individual element of the A matrix. So that will give us 16, 24, -8, 0, -40, and 32. So that's your answer for number 2. For number 3, we're supposed to multiply the A matrix times the C matrix. So we need to check and make sure that's even possible. And we do that by looking at the dimensions. So the A matrix is a 2x3. The C matrix has 3 rows with 1 column. It's a 3x1. And so to make sure that multiplication is possible, you check out the inside numbers from each pair of dimensions. If they match, it's possible to do it. And then these outside numbers are important because they tell us what the answer is going to look like. My answer should be a 2x1 product matrix. So I'll just go ahead and set this up. Here's matrix A. And we're going to multiply matrix C. You have to keep them in this order. A to the left of C. And when you multiply matrices, it's always row of the left matrix. So it's row of the left times column of the right. And we only have 1 column, of course, so that's not too tough to determine. So I'm going to go ahead and set up a blank 2-row, 1-column matrix. That's just one element over another, 2 rows with 1 column. So this top row, this would be row 1, column 1. You don't have to write this, but just so you'll see it. So that means I'm going to have to use row 1 of the left matrix times column 1 of the right. And so you just match up the elements. The first element of the left times the first element on the right, 2 times 2. And you're always adding the second element, which is 3, times the second element, which is 9. And then finally the third element, which is -1, times the third element of the right, which is 4. And you just put all those products together, and 4 plus 27 is 31, minus 4 makes 27. And now we're going to do the same thing for the bottom. So first element of the left times first element of the right, second element of the left times second element of the right, third multiplied times third. So 0 plus negative 45 is negative 45, and then plus 16 is negative 29. So that's your answer for number 3. C times D. The C matrix is again 2, 9, 4, 3 by 1. And D is a 1 row with 3 columns, negative 3, 2, negative 1. And it is possible because the inside numbers of each pair of dimensions match. So this is going to be a 3 by 3 product matrix. So you might want to just go ahead and make a blank 3 by 3 matrix. And so this spot represents row 1, column 1, which means I'm going to multiply row 1 of the left, which is really just one number, times column 1 of the right, again, just one number. I just multiply those two numbers together, and that's going to be negative 6. And then I'll erase my circle here. Now, this is row 1, column 2, so this time I'm going to do row 1 of the left times column 2 of the right. And again, that's just multiplying two numbers together. So you kind of get the picture of what's happening here. This is row 1, column 3. So I'm going to use row 1, which is still just that single number, times column 3, which is also a single number. And so you kind of get the idea. Now the middle row will just be multiplying 9 times each one of these numbers. So negative 27, 18, negative 9, and then negative 12, 8, negative 4. And so there is your answer for number 4. And then finally we have the B matrix, which is a 2 by 3. So B is a 2 by 3. And then D, of course, we've already written that here is a 1 by 3. Well, this isn't possible because these inside numbers do not match up. So we're told in the directions that if it's not possible, just put undefined. You'll do the same thing on your test if that happens. And there's your answer for number 5. Number 6 is the idea of when two matrices are equal to each other, that means we can make corresponding elements equal to each other. So what I mean by corresponding elements is this element corresponds, or you could think of matches up with this element. So I can make those equal to each other. And that's also true of this element. It matches up with this one. I can make those equal to each other. And what I have here, when I've got two unknowns, unknowns meaning I don't know what M is or N, I don't know either one of them, then I can solve, this is another word for a system. And I can solve a system really with we got many options. We can do substitution, elimination, graphing. We also now know how to do Cramers Rule. You could pick any of these. It sets up really easily though for elimination because of these ends. They're already opposite each other, so all I have to do is add all of the like terms together. 2 plus 1m is 3m. These ends would cancel, and 15 plus negative 3 is 12. So I've solved for m, and now I can use that value for m to solve for n very quickly. Just go back to either one of these equations, doesn't matter which, and replace m with 4. I'm just going to use the bottom equation. So I replaced m with the value that we came up with, 4, and now I'm going to solve for n. Just subtract 4 from both sides. So there's my final answer for number 6. M is 4 and n is negative 7. Number 7 is solving for a matrix, this matrix called X. So first I need to undo subtraction with addition. So I'm going to be adding this left matrix to the right matrix. So just match up the elements. 5 plus negative 2 is 3. 10 plus 0 is 10. Negative 15 plus 1 is negative 14. And 9 plus 4 is 13. All right, so we've taken care of step 1. Now step 2 will be to undo multiplying by 2. And I'm going to do that by multiplying by a half. So my matrix that I'm looking for will be obtained by taking 1/2 literally times each one of these elements. You don't have to show this. I just wanted to over illustrate. Every single element will be multiplied by a half. So that's 3/2. 10 times 1/2 is 5. Negative 14 times a half is negative 7. And 13 times a half is 13/2. And so there is my answer for number 7. So when you're undoing multiplication by a number, no big deal. You just multiply by the reciprocal of that number. In this case, that was 1/2. But when we get to numbers 8 and 9, we're not multiplying a matrix by a number. We're multiplying a matrix times another matrix. So this is where you're going to need to know how to find the inverse. All right, knowing what the inverse of 2 is, no big deal. You just flip over 2 and you make it 1/2. But knowing what the inverse of a matrix is, that's a little bigger deal. And we've learned how to do that. It starts with finding the determinant. So the determinant would be negative 24. Start by multiplying A times D. And then you subtract the product of the other two. So the determinant is going to be negative 29. So I'm going to write up here the general way to find the inverse, and you just need to make sure you're good with this on the test. So you're essentially going to be multiplying 1 over whatever the determinant is times this version of the original matrix. All right, so make sure you change it up, and then you multiply by 1 over the determinant. So here's what it looks like. 1 over negative 29. And that's going to be multiplied. Notice the negative 3 and the 8 are going to switch. The other two elements are going to change. They stay put, but they become opposites of what they are. All right, so when I multiply negative 1/29, I get the inverse. Okay, so that is the inverse. And now to get my final answer, I need to multiply the inverse times this matrix on the right. Okay, you'll always find the inverse of the matrix beside the variable. We did that. And then use that matrix to multiply times the right side. So now we just have to remember how to do matrix multiplication. This is a 2 by 2, this is a 2 by 1, so I'm going to end up with a 2 by 1 answer for x. 2 rows with 1 column. So remember, matrix multiplication, it's always row of the left times column of the right. And obviously we just have 1 column, so that's pretty easy. So I just match up the elements. I'm going to write it out and then I'll erase it. Negative 8/29 multiplied times 29. And then the second two elements, 5/29 times 58. Well, the 29, think of this as 29 over 1. Those are just going to wipe each other out. Negative 8/29 times 29 over 1 means that I end up with just negative 8. And then here, maybe looking at it this way would be a little bit easier. 29. 29 does go into 58 2 times. So the end result of multiplying those two is just 10. So when you do negative 8 plus 10, you just get 2. So look like we might have a ugly fraction answer, but it turns out that we don't. And then we had to do the bottom row, same thing. So 1/29 times 29 added to 3/29 times 58. I'll just go ahead and say that it's 58 over 1. Well, a number times its reciprocal is always 1. Easy enough. here we are again, 29 goes into 58 2 times, so all we're really doing is 3 times 2, which is 6, and 1 plus 6 is 7. So there's my answer for number 8. So make sure that you're good with finding the inverse of a 2 by 2 matrix. We have an additional step in this problem that we did not have in number 8. We have to subtract. We have to do the opposite of addition here first. So let's go ahead and show that step. So it starts with this left matrix, and we'll be subtracting this, it starts with the right matrix. I just checked it. That's the right side matrix, and we're going to be subtracting the matrix on the left from that. All right, so start with 6 and then subtract 2. 6 minus 2 is 4. 2 minus 7 is negative 5. Negative 2 minus negative 3 is 1. And 3 minus 4 is negative 1. All right, so now we're left with finding the inverse of this matrix. Always find the inverse of the matrix being multiplied by the variable. So that starts with the determinant, 8 minus 7. All right, always enjoy seeing a determinant of 1 because that makes the math easy. Instead of multiplying by something like this, we're basically just multiplying by 1, which is easy math. And 1 is going to be multiplied by remember, we have to change up this original matrix. So 2 and 4 are going to switch places. And the other two elements don't move, they just change. So of course, multiplying by 1 means that's going to be the inverse. Okay, inverse. And now we're ready to multiply times this matrix on the right. So key point here, we mentioned this in your notes when we actually covered this lesson, but it's very important that when you do this matrix multiplication and you got the inverse and you're ready to multiply, the inverse has to be on the left. If you change the order of these two matrices, if you were to switch these, you're going to get this problem wrong. All right, so always set the inverse in your multiplication to be the one on the left. All right, so now we're ready to do the matrix multiplication. And my final answer for X is going to be a 2 by 2 matrix. So let's see if we can do some mental math. So it's going to be 2 times 4, which is 8, plus negative 7 times 1, which is negative 7. So that's 1. All right, so erase my rings here. All right, so for row 1, column 2, I'm going to do 2 times negative 5, which is negative 10, plus negative 7 times negative 1, which is positive 7. And so that's going to be negative 3. And I just keep on working through this until I get all 4 elements of the product. Now I'm doing the bottom row, negative 1 times 4. First element with the first element, that's negative 4, and then 4 times 1, which is positive 4, that makes 0. And then finally, bottom element is negative 1 times negative 5, plus 4 times negative 1, and that is 8. Whoa, hold on. Just write that. 4 times negative 1 is negative 4. So 5 plus negative 4 is 1. Okay, I think we got it. All right. All right, we're ready to move on to problem number 10 and Cramers Rule. So Cramers Rule is all about finding, for us, since we're only dealing with 2 variables, we got to find 3 determinants The first one I'm just going to call capital D, and it's going to be just the determinants of what we call coefficients. Just take the numbers in front of the variables. The first column should be the x coefficients, the second column should be the y's, and find that determinant. So negative 10. You always subtract when you're finding determinants. Negative 10 minus 3. Negative 10 minus 3 is negative 13. All right, now we're going to find the determinant called d sub x, and this is where we take the constants. Constants are numbers that do not have variables attached. And we put those constants in place of the x's. So d sub x means replace the x, the two x coefficients. And the y's are going to stay like they were, and we find that determinant. So negative 2 minus 24 is negative 26. Now, this is a key part that some people miss. You're always dividing. This first capital D determinant that you find is always going to be used as a divider to get x. Okay, if you just left your answer as negative 26, you haven't found x yet. You found a determinant, but to find the true value of it for x, you have to do this division. So x is 2. All right, now we're going to do the determinant called d sub y. And we're going to put the x's in place, but this time we're going to let 1 and 24 replace the y's. And do that determinant. So 5 times 24 is 120, minus 3, that's 117. But again, always divide by this first determinant, this determinant of the coefficients. And when you do that, you get negative 9. So final answer as an ordered pair, x is 2, y is negative 9. Now, if you have time on your test, those of you who like to finish early and you've still got a few minutes left, you are welcome to use another method like elimination, substitution. Probably elimination would be easier in this case, but you're welcome to use either one and just see if you get that same answer. So these are more familiar methods. Cramers Rule is a fairly new method, but you should get the same result. So I would encourage you, with the time that you have left, just check out another method, and you might discover that you made some little mistake in coming up with one of these three, or maybe more than one of these three determinants. So I always think that's a good idea, to check your work using other methods that we've learned. Okay, now we're moving into some statistics, and this first 11 through 13, mean, median, and mode. So for the mean, we just add up all the numbers, and then we divide by the number of terms. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you add all those numbers up and then divide by 13, and that will be the average. So the sum, just hoping you can take your calculator and add those up. The sum of those numbers divided by 13, and we're told in the instructions to round to the nearest hundredth. That's 2 decimal places. So the mean, also known as x bar, is 47.62. For the median, you can use this little technique. If you just start working your way to the middle, marking off pairs from both ends. And median means the middle term. And when there's an odd number of terms, like we have here, there's 13, we can actually see the median. We don't have to calculate it. So the median is the number 48. The mode, you don't always have a mode, and sometimes you have more than one. The mode is the one that occurs more frequently than any other. Some people are mistaken thinking that the mode is any number that appears more than once. Well, that's not necessarily true. It's just the one, or maybe there's more than one, that appear more than any other. All right. And so you can probably see where the number 49 appears twice, and so does the number 41. No other number appears that many times, so we have in this case what is known as bimodal. There are two modes, the number 41 and the number 49. All right, for a box and whisker plot, we just draw a little number line. We have to know the median, which we've already found, and that's also known as Q2. That median, as you can tell, separates our data up into two smaller groups. So we have two groups of 6 on either side of 48. And so we just need to find the median of each of those groups. And so the middle number of the left group would be 44.5. And then the middle number of the right group would be 51. So 44.5 is called Q1, 51 is called Q3. And the box and whisker plot is also known as the 5-number summary. Some textbooks will use that language. And the 5 numbers that we're accentuating are Q1, 2, and 3, along with the low number and the high number. So we're going to shine the spotlight on those particular 5 numbers, and they can be useful in helping us make decisions. So I'm just going to do, I'm going to start at 40. I just need to have a number line that will be able to capture all these numbers. And I'm just going to go in units of 2. So come up with some predefined number line that you will plot your 5 numbers on. Don't let your number line just be the 5 numbers. Okay, be somewhat creative. So as long as your first and last numbers on your number line will include your low and your high, you should be in good shape. So 41 would be right in between 40 and 42. That's my low number. Q1 is 44.5, just a little bit to the right of 44. That's Q1. Q2 is 48. Q3 is 51, right in between 50 and 52, of course. And then finally 54 is my high. So there's my 5 numbers. For Q1, 2, and 3, they get little short vertical lines drawn through them. And then we draw a box around those short vertical lines. And then for the low and the high, we just extend little horizontal lines out to those. And there is your box and whisker plot. For the range, range is just the difference between the lowest value, or the highest value, we'll start there, 54, minus the lowest value, which is 41. So in this case, the range is going to be 13. Interquartile range is the difference between Q3. Make sure Q3 is always first. Interquartile range should never be negative. So it's Q3 minus Q1, and Q3 we said is 51. Q1 is 44.5. And so we just find that difference, and that equals 6.5. So those are actually 2 separate answers. It'll be the same way on your test. And now we're going to do a standard deviation problem, which includes finding the mean. So first thing we'll do is add these numbers. So just add them up. And then to get mean, of course, you're going to divide, in this case, by 5. So the total of the numbers divided by 5. Let me just go ahead and set up our little table here. So you'll list out the numbers first. And these do not have to be in any particular order. All right, and then you come up with the mean, also known as X bar. So hopefully you've had a chance to add these up and then divide by 5. And you came up with an average or mean of 50. And so you just need to write 50 one time, and then you can just draw a line to show that 50 really is going to fill that whole column. The next column should be the difference between these, and order matters here. It needs to be the first number, the original number of the data, minus the mean. All right, so just take your calculator and work through those. All right, so 48 minus 50 is -2, and then 53.2 minus 50 is 3.2. 52.3 is 2.3. 46.6 minus 50, -3.4. And 49.9 minus 50 is -0.1. Okay, and then as we move to the right, we take these numbers that we just calculated and we square each one of them. And remember, there should never be a negative number in this column. You cannot square a negative number and get a negative result. So -2 squared is +4. 3.2 squared is 10.24. 2.3 squared is 5.29. -3.4 squared is 11.56. And -0.1 squared is 0.01. Okay, and it's this column, this is the only one of the columns that really needs to be added up. So just grab your calculator and come up with the sum of those 5 numbers. And I'm doing the same thing. And I got 31.1 as the sum of that column. And so now we're ready to use our standard deviation formula. Make sure you know this. It's pretty easy if you've done all of this work leading up to it. It's that sum that we just came up with, 31.1, divided by the number of terms, which is 5. And we're going to do the square root of that whole fraction. So you can do this all at once. It's the square root of 31.1 divided by 5. And our instructions say to round to the nearest tenth. So to the nearest tenth, we will say the standard deviation is 2.5. It's 2.49399 rounded. Okay, moving on to numbers 18 and 19. To find the numbers at any particular percentile, you first need to know how many terms are in your data. And so if you count these terms up, you should get 15. We have a total of 15 numbers. So to find the one that's at the 20th percentile, I'm going to multiply 15 times 0.20. It's 20% as a decimal. Well, 15 times 0.2 is 3. So remember, percentiles mean you did better than. So if these were grades, I know they're kind of big, but let's just pretend like they're grades, and you were at the 20th percentile, then you're the first number that's better than, in this case, the previous 3. So in other words, you are the 4th scorer in the ranking. So all we have to do is come over here and mark 174, and we'll just mark that as the 20th percentile. All right, and then for the 80th, we do the same thing. We take the number of terms and we multiply by 80%, and that's 12. So I'm looking for the score. Maybe these are bowling scores. I'm looking for the bowling score that's better, the first one that's better than the previous 12, which in other words is talking about the 13th. And again, it's important that they're in order. So it's like a ranking. What number is the 13th? Well, this is the 15th, 14th, so 188 would be the one that's at the 80th percentile. So So 174 is the answer for the 20th, and 188 is the answer for the 80th. All right. Next problem. We conducted a survey. 300 students were surveyed. 68% will vote for candidate C. What's the margin of error? Well, the 68% really isn't needed. The margin of error formula, and in this particular problem, it's not. The margin of error formula is always plus minus 1 over the square root of n, and n is the sample size, or how many people, in this case, were surveyed. So to get our answer, it's plus minus 1 over the square root of 300. All right, so let's do that on a calculator. 1 divided by the square root of 300. And you can just round this to the nearest percentage. So in your calculator, it says 0.057735. So you can either slide the decimal 2 to the right, or you could go ahead and, in your calculator, just say times 100. So you're looking at 5.77. So to the nearest percentage, it would be plus minus 6% is our margin of error. All right, well here we're going to use the same formula, but this time we're given margin of error and we want to know what the sample size is. So same formula as I wrote up here, but we can go ahead and put in 2%. You don't need the plus minus because when you're coming up with a sample size, you never have a negative number of people. 1 over the square root of n. We talked about this in class. Since n is in the denominator, we need to flip these over. So mathematically, you're raising both sides of this to the negative 1 power is really what you're doing. It's not just magically happening. We have to do some math to make it happen. And now, to get rid of the radical, we just square. And since we're having to do that to the right side, we must also do that to the left. So your answer will be, if you do this all at once, it's easy. If you just do left parentheses and then 1 divided by 0.02, close your parentheses, and then raise that little caret button to the second power. And we have a sample size of 2,500 people that will produce a margin of error of 2%. So the higher the sample size, the lower the margin of error. All right, so the previous 2 problems all rolled into one. Previous 3 problems, I guess. A survey of 900 students, 375 bring their lunch to school. The sample proportion is just that fraction of the ones that do bring their lunch to school divided by all the students who were surveyed. And you can just do this to the nearest percentage. 375 divided by 900. And it's 0.41666, so we're just going to say to the nearest percent, it would be 42%. The margin of error, we just looked at that formula. Margin of error is plus minus 1 divided by the square root of n, and n is how many total students were surveyed. In this case, that's 900. So 1 divided by the square root of 900 is 0.033, so to the nearest percent, that's plus minus, don't forget plus minus 3%. And then we're going to build an interval where we feel confident that the true population proportion, we can't say definitively that 42% of everybody brings their lunch to school. So because margin of error needs to be built in. So using this margin of error and using our original sample proportion, we build what some people call a confidence interval. So just take 42% and subtract 3%, and then take 42% and add 3%. And now we feel a little bit better that we have a true representation for these people who bring their lunch to school. All right. For this problem, number 23, you need to know the z-score formula. And I'll just repeat that for you. It's value, or the number, minus the mean, divided by standard deviation. So this time it's a little different. You're having to find standard deviation. You've got to find this number at the bottom. So given the z-score of 4, given the value of 55 and the mean of 35, it's like we're finding this number at the bottom. If you just want to put x, it's fine. So solving for x means I'm going to multiply by x on both sides, and I can go ahead and do this subtraction. 55 minus 35 is 20. So pretty easy to solve for x. The standard deviation is going to be 5. 20 divided by 4. Okay, so for 24 through 26, we have to know the standard normal curve. So I'm going to go ahead. I want you to show this on your test. So the mean is 72, so you can just let that be your center number, and then use the standard deviation to build the rest of this x-axis. So add 10 and subtract 10 going to the left. Place the percentages, and you don't actually have to draw the curve, but you should know these percentages within one standard deviation of the mean. That should include or contain a total of 68% of our data. When we go out to positive and negative 2 standard deviations, that's another 13.5% of the data. And then the rest will be out here, 2.5%. will be within 3 standard deviations. So all 100% of our data, if it's a normal distribution, and we're told that this is, then our data should be contained like this. And these numbers on the x-axis represent ages. So we want to know how many, there's 400 total runners, athletes. We want to know how many are between 72 and 82. So remember, these numbers represent ages. So if we want to know how many are between 72 and 82, well, the percentage of those is 34%, but we need to multiply 400 times 34% to get the actual number. So 400 times 0.34, that's 136 runners are between 72 and 82 years old. Okay, so for the ones that are less than 72, so here's 72 years old, that would be all of these, of course. So we take these 3 percentages, which of course is just 50%. We take the number of total runners, and if you multiply by 50%, that's 200 runners are in that age group. And then finally, using the same normal distribution, the number of runners that are between 62 and 92, so that's the 34 plus 34 plus 13.5, that's 81.5% of the runners, so 400 times 0.815, see how many runners that is. And that's 326. All right, so there's your standard normal curve problems. And then we get to some probability, and we're just about done. So the spinner that we're working with is pictured. This problem is, if you notice, it's got the word or, so that always means we're going to be adding. And that should also tell you that we're dealing with either mutually exclusive or not mutually exclusive. These types of problems involve adding probabilities together. And if it's not mutually exclusive, then we'll not only will we be adding, we will also need to subtract. All right. So let's find each of these separate probabilities. Probability of prime on this spinner. Well, the prime numbers are 2, 3, 5, and 7. So there's 4 prime numbers out of a total of 8. So we got a 1 in 2 likelihood of landing on a prime number. All right, now let's see about the probability of landing on a number greater than or equal to 6. Well, that's 6, 7, and 8, 3 of those. Now, to ask ourselves, if it's mutually exclusive, then there's no way for a number to fit both of these descriptions. But in this case, that's not true because the number 7 is both. So this is what it means to be not mutually exclusive. We need to calculate the probability of a number being both. I'll just describe it, both prime and greater than or equal to 6. There's one of those out of a total of 8. So to get my final answer, I'll just leave it in terms of 8s, since all of these are. I take the probability of prime, I add the probability of greater than or equal to 6, but if it's not mutually exclusive, you'll always be subtracting the probability of a number, or it could be more than one, that fit both descriptions. We subtract that off. And now that's 7/8 minus 1/8 is 6/8, and if you can reduce, you should always reduce. So there's a 3 in 4 likelihood that with one single roll, we will land on either a prime number or a number greater than or equal to 6. All right, let's take a look at 28. This is a number cube problem. Again, you see the word or, so you know you're going to be adding. You know then that this is either going to be mutually exclusive or not. So let's see. Find the probability of even on the number cube. Of course, that's 3 out of 6. Then find the probability of a number being greater than 4. Notice it doesn't say or equal to 4. So that's 2 out of 6. That's just the numbers 5 and 6. Now ask yourself, is it possible for a particular number, or maybe there's more than one, that could be both, even and greater than 4? Well, hopefully you're thinking, well, the number 6 fits both of those descriptions. So again, there's a 1 in 6 likelihood that the number that we land on or that pops up is both of these. So it's very much like the previous problem. This is going to be not mutually exclusive. So we take 3, 6, we add 2, 6, and then we always have to, for not mutually exclusive, we'll be subtracting another probability. So 5, 6 minus 1, 6 is 4, 6, which reduces to 2/3. Okay, now 29, we have 2 different boxes of marbles, various colors of marbles. We choose 1 marble from each box. I want you to notice the language here. What is the probability that you get a blue marble and, it's a key word, because we talked when we did this lesson that and goes with multiplication, just like or is going to describe addition. So with multiplication, this is where we're talking about independent versus dependent events. So independent events means that one action has no effect, no bearing on the outcome of another. And that's really what's happening here, because they're 2 separate boxes. Choosing a marble from one box does not affect the outcome of my choice from the other box. They're 2 separate boxes altogether. So we are dealing with an independent situation here. So for this, I just find each separate probability because there's 2 different boxes, and I multiply them together. All right, so let's see. With one choice, what's the probability that I'm going to get a blue? Well, the box that contains blue, we'll just say it like this. The probability of blue out of that left or one box is 30 blues out of a total of 50, which would reduce to 3/5. And then the probability of black from the other box, that's completely separate. Let's see, there's 47 black out of a total of 57 marbles. That can't be reduced, and so now we just set up these to be multiplied together, and then that will give us our answer. All right, so we can do a little canceling here so that we don't have to worry about giving an answer that could be reduced, but it's not. 3 goes into 57 19 times. So my final answer will be 47 over 5 times 19. I believe that's 95. Just double check it to make sure. Yep. 47 out of 19, and the instructions say to leave your answer as a reduced fraction. And so that's it. So that takes care of the material that you will be responsible for on this test. I hope this helps you, but if you need more help, you're always welcome to email me or stop by during academic support. And prepare well, and I'll see you next time.